Hey guys, it's me ActiveXSploit back again with a new video. And before starting today's video, first of all, I want to thank you all as the channel recently hit 1000 subscribers. I really love your support, and you guys also make sure to leave a like on this video and subscribe to the channel as it boosts me a lot to upload videos on it, right? So in today's video, we will start off by some basic malware development in C. So today's topic is going to be a beginner level topic in which we get familiar with socket programming in C. Alright. Also, if you don't know what is socket programming, or if you don't know C, don't worry, I'll be explaining all of it in today's video very clearly. Also, for the development part, our server is basically going to be on a Linux machine, which is my Kali Linux machine, and our client is going to be a Windows machine, which will be connecting to the server. And on Linux, I have GCC installed, and indeed it comes pre-installed on Kali Linux distribution, but if you don't have it, you can simply install it on your own. And on Windows, I have Visual Studio 2019 installed with the build tools, which I'll be using for compiling my final program. Right. So with that being said, let's actually get started. First of all, let's actually have a look at the server workflow in socket programming. So for server side, we use the following functions, and all of these functions are present in the sys header file, and we have to include this header file before using any of these functions listed over here. Alright, so first of all, we use the socket function to create a socket object, and for our purposes, we are going to be using the we will basically create a TCP socket which uses IP version 4 for communication, right? And then we use the bind function to actually bind a server on a particular port and a host, right? And the host in our case is going to be our Kali Linux machine. And before we actually declare the bind function, we have to specify a structure, right? We have to declare a structure which holds some important information which is actually important for the bind function. All right, we have to use that function with the use that structure with the bind function. All right, don't get confused at this part. I'll be explaining all of this when we get to the programming part. All right, and then we finally use the listen function for listening for incoming connections. And then we use the accept function to actually accept any of the connections which are coming to the server, right? And once we accept the connections, we can start our sending and receiving the data, all right? We can start sending data, or we can simply receive data, all right? So this basically is a basic workflow of a server in socket programming. All right, now let's actually have a look at the client side workflow in socket programming. And for the client side, we will be using the WinSock2 library. Now, as we are on Windows, we are going to be using the WinSock2 library. All right, if you are programming your client on Linux, you have to use the same library, which is syssocket.h library. All right, but as we are going to be as we are using Windows, we have to use the WinSock2 library for socket programming. Right now, what is the difference between the WinSock2 library and the syssocket library? All right, now there is not much difference. The workflow is still the same. Okay, so the workflow of client and the server still stays the same in both of the libraries, but the syntax in the WinSock2 library is actually a bit different. So don't worry about the syntax part. I'll be showing you everything when we get to the programming part. Alright, for now, the only important thing for you is to understand the basic workflow of a client and a server. So the functions used in client side is the same. So we use the socket function to create a socket object, and then we use the connect function to actually connect to our target. Now, if you remember, I previously mentioned that before using the bind function, we have to declare a specific structure which is used by the bind function to bind our server. In the client side case, it is actually the same for the connect function. All right, you basically have to declare a structure at first before using the connect function, and you have to specify some information in it which is important for the connect function. All right. So we basically first of all declare a structure and then use it with the connect function. All right. Now, after we have connected to the server, we start our basic operations, which are sending and receiving data. All right. So now I hope you have understood the basic workflow of a server and a client in socket programming. And if you have any doubts, feel free to ask them in the comment section, or you can simply join my Discord server and you can ask your doubt over there. So now let's get to the programming part, and we will first of all get started out by programming our socket server. So I'll just simply switch to my Linux machine. And over here I have created a directory called maldev, and I have another directory in the same folder called socket server. So I'll be using a normal text editor actually to program the socket server. I don't have any better IDE on my Kali Linux machine installed. So you can use any IDE of your choice. I won't be using any IDE over here because my Kali VM is a virtual machine, and if I use a IDE on it, it's actually going to lag, right? So I'll be first of all saving this file in my maldev folder, and I'll just name this as socket server.c. And now we first of all start out by simply declaring the standard input output header file, and then we include the required libraries, which is one of them is the socket library, and then we have the types library, and finally we have the net in library. Right now, if you don't understand what these are used for, don't worry, when we go further you'll actually understand everything and why do we need them. All right, now I'll be simply declaring a main function, so int main, and now I'll be declaring all of the required variables. All right, so I'll say int server socket. So this is basically used for I'll be actually using this variable for creating a socket and storing its value in this particular variable. So we just say used, or we can just say used. You can actually put a comment, and let's just say used for creating socket. All right, and now we can simply create our socket, or let's actually first of all declare all of the variables which we are going to need. So I'll be also declaring the client socket, used for used when, you can actually say used for accepting connection, and then we also need to declare the structure which I was talking about, struct sock adder underscore in, and we can just name this as server adder. Structure required by the bind function, so I can just name it as this. And I'll also actually create a buffer of size, let's say 500 bytes, which is actually going to hold our message, and we can just say hello from the server in here. Right, so this is basically going to hold our message, and once we accept a connection, we will actually send this buffer to our client. All right, so now let's actually create our socket. So we can just say server socket equals to socket, and the socket function takes 3 arguments. So first one is going to be af underscore inet. So af underscore inet is it basically means that we have to use IP version 4, and then we declare our declare the type of the declare the protocol type actually, which is going to be TCP, and it is sock underscore stream. So sock underscore stream is actually used for creating a TCP socket. If you want to create a UDP socket, you'll actually have to use sock underscore dggram, right? And then we finally specify a 0. We don't have to specify anything else at the end, so we finally specify a 0. Also, one more thing, if you don't understand or if you want to look in depth of any of the functions which we are going to use, you can just simply say you can simply open up your terminal and say man, and you can simply type the function which you want to use. So let's say if I want to view information about the socket function, I'll actually increase the size and I can just say man socket, and as you can see, you literally have a big programming manual over here for the socket function. So as you can see over here, the socket functions take 3 parameters. So we have the socket family, which is going to be AF underscore inet, and then you have the socket type, which is going to be sock underscore stream, which is basically a TCP socket. And then you have the protocol. So we leave the protocol to 0, right, as we want to use the TCP socket. So you can basically scroll down and read everything over here which you want to. So I'll just quit out of this. I'll clear my terminal and I'll just go back. Alright, so now I can actually leave a comment over here so that you understand what I'm using what this line does. So it basically creates a TCP socket, and now we finally declare, we actually specify the information for our structure which we just declared over here. So we can just say server adder dot syn underscore family. Whoops, that's actually not correct. We have to put an equal to sign over there instead of those brackets. So we simply set this to AF underscore inet, and then we specify the port which we want to use. So syn server underscore adder dot syn underscore port htons 9001. So for using the htons function, I guess you have to include the stdlib.h library, I guess. Let me actually quickly see that in man database, but it doesn't work. Or let me actually open up Firefox and quickly check up on that one. So htons function in C. Yep, there we go. We have the man page in here, and oh yeah, we actually already have declared it. So it's in the net inet /in.h library, so we don't have to worry about that. So we'll be using the htons function to convert this port number to the required type by the structure over here, right? And now we finally specify the address, the host which we want to set, all right? So it's basically going to be server underscore adder dot syn underscore adder dot s underscore adder, and we simply say inet underscore adder, and into brackets we specify the host. So I'm basically going to set this to my IP address, and my IP address is 192.168.1.2. so I'll just go back and I'll just set this to 192.168.1.2. and so this is all we have to set. So we finally have finished up setting the structure, right? And now we simply use the bind function to bind the server. But first of all, I'll actually declare comments in here so you understand what we are using this for. So I can just say declaring the type, declaring the port number to listen on, declaring the host. Alright, so now we can simply declare the bind function, but before actually declaring the bind function, let me actually show you the man page for that one. So we can just say man bind Whoops, there is no bind. There is no man page for bind or what? Yep, there is no man page for bind. It should be there, but I don't know why it is not present, so I'll just say man bind. Uh, yep, there we go. Now, the bind function actually takes three arguments. So first of all, it takes the socket file descriptor which you have created. So in our case, the socket file descriptor, the socket object is this, which is the server socket, and then it takes it basically we need a pointer to the structure which we recently declared, which is the server underscore adder structure, and then it basically takes the size of that particular size of that structure which we have created. So let's just say bind, and then we first of all pass the socket which we have created, and then we pass a pointer to the structure which we have defined, which is struct server underscore adder, and then we pass the address of server underscore adder, and then we finally get the size of the structure. Alright, and I can just comment this out, comment a line out over here. I can just say bind the server, and now we simply use the listen function to actually listen for connection. So the listen function takes two arguments, the first one being the socket which we have created, and the second one which is the number of connections which we want to actually listen. Alright, so we can just say server underscore socket, and we'll just listen for 5 connections for now, or we can just set this to 1, or we'll actually set this to 5. Alright, and now we basically accept connections. Alright, and for that we are going to store all of the values in the client underscore socket variable. So what we'll do is I'll actually say client underscore socket equals to accept, and we basically accept the connection. And if you actually have a look at the man page for accept function, it is not present over here too, so I'll just go off in here and I'll just say accept in here, and yep, there we go. So the accept function takes 1 2 3 4, yeah, it takes 4 parameters. Nope, it's 3. Alright, so it takes 3 parameters, and first of all we have to do is simply specify the socket which we have created, which is the server socket over here, and then we are going to leave the last 2 parameters as null. Alright, we don't need them. So I'll just say server underscore socket. The first parameter is basically going to be the server underscore socket, and we leave the last 2 parameters to null. Alright, and finally now I'll just actually print out saying that a client has connected. So we can just say client connected, and now as we have a connection, what we'll do is we'll actually start receiving and sending data. Right, so first of all we are simply going to send data. So what I'll do is I'll just say send, and the send function actually takes it takes, I guess, 4 parameters. So the first parameter is basically the client socket which we have over here, and the client socket is which basically is the connection. All right, so we have stored the value of the accept function in the client socket variable, so we'll be using it in the send function to send the data to. So we'll just say client underscore socket in here, and then we basically specify the buffer which we want to send. So the buffer over here in our case is this, so we just say buffer in here, and then we finally specify the size of the buffer which we want, which we are willing to send. All right, so we'll just say size of buffer, and we finally leave the last parameter as 0, as we literally don't have to do anything to that. Alright, now we also actually have to create one buffer for receiving data. I forgot that to mention at the start, so I'll just mention it now. So I'll just say char recv underscore buffer, and the size of this can be 500 bytes, and I'll just leave it as it is. And now what I'll do is I'll actually use the receive function in order to receive for data. Right, so now I can just say receive, and the receive function is exactly same as the send function. Right, so first of all you specify the client socket, so client socket, and then you specify the buffer where you are actually storing the data, the received data. So in our case it is the receive underscore buffer over here, and finally we specify the size of the receiving buffer, so size of receive underscore buffer, and then you leave the last parameter as 0. Alright, and now we can actually print out what we have received. So I can just say printf, and we can just say something like client has sent, and we can just print it out. So I'll just print out recv underscore buffer. Oh my god, sorry for that. And now I can simply close the connection. So we simply use the close function in order to close the socket. So I'll just close the server socket in here, and we'll just exit out of the program. And finally I simply return 0 over here, and I'll actually also put some comments in here so that you can understand what we are doing. So over here we simply accept incoming connections, and over here we send data from the send data. Yeah, we can just name this as sending data to the client, receiving data from the client, and we simply print out the data sent by client. Right, whoops, it's actually client and not client. And then we simply close the connection and we exit out of the program. Right, let's actually check if there are any sorts of errors in the program. So yep, there we go. As you can see, I have not specified the semicolon, so I'll just specify the semicolon in here, and yep, everything else looks good. So let's actually compile the program now. Right, so I'll just, yep, I have to remove the standard lib.h library from here, and then I can just use GCC. So I'll just say GCC -o socket underscore server socket underscore server.c, and yep, there we go. The server has compiled, and we have some warnings on our screen, but it's okay. All right, so now what I'll do is I'll actually test the server. So I'll just say /socket underscore server, and I'll open up a terminal over here, and I'll just increase the terminal size, and now I'll just connect to the server which is running on port 9091. Whoops, it's actually 9001. And as you can see, when we connect, we have a message printed on our netcat side which says hello from the server, and over here it says client connected. So now we can confirm that our server is indeed working. So we can just exit out of the connection in here, and whoops, we actually forgot to check the receive function. So I'll actually send something. So I'll just say test, and as you can see on the server side, test gets printed. So yep, this is indeed working. So now let's actually get to the client side programming. So I'll just exit, whoops, not exit, I'll just actually save this, and I'll go back to my Windows machine. Alright, so let's actually get to the client side programming part, and I have my Windows machine in here. Also, I am really sorry if the screen is a bit small for you, but don't worry, I'll be actually making it big. I'll be zooming in while I'm editing the video, right? So I have my Visual Studio Code opened up, and I have a file called socket underscore client.c created, and we can simply start the client-side programming. So first of all, I'll include the winsock2 library, so winsock2.h, and then I have to include the ws2 tcp ip.h, and then I'll just make a pragma comment lib ws2 underscore 32.lib, and then we can simply create our main function, so int main. And our first step would be actually initializing a socket. All right, so we basically have to not socket, we actually have to initialize winsock, all right, before performing any of the socket operations. So for that, we first of all have to create a WSA data structure. So we just say WSA data, and we can just name this as WSA structure, all right. And now we basically initialize socket, not socket, we basically initialize winsock. Alright, so now what we have to do is we simply create a variable which is basically going to hold the result of the initialization. Alright, so I'll just say int result, and now what we can do is we basically have to use the WSA startup function to actually initialize the socket. All right, so we'll just say WSA startup, and we have to say make word, and then we specify the version of winsock, which is going to be 2. So it's so the winsock version which we are using is version 2, and then we basically pass a pointer to the WSA data structure, which is WSA structure in our case, right? And now we store the result of this particular function in the variable called result, all right. And now we can actually place a comment in here, which can be initialize socket, winsock, sorry for that, I keep saying socket. And then we basically put an if statement in here, if not result, we can it's actually if result is not equals to 0, we can just say printf, we can just print something, we can just say winsock initialization failed, and we can just return 1, right? And now we can actually start our socket programming. So first of all, I'll actually declare the socket structure in here, and I'll just say socket. I can just say client socket, and now I can just go off in here, and we can create a socket function. Yep, I'll just do it off over here. So client, I'll just say socket equals to I'll actually say client underscore socket is equals to socket, and I'll just specify the family type, which is going to be AF underscore init, and the socket type which we want to create, which is going to be TCP, and sock underscore stream represents the TCP socket, and for the protocol we'll just leave it to 0. Alright, now we finally declare a structure which we also declared while we were programming the server side. So I'll just say struct sock adder underscore in, and I'll just say client adder in here, and now I'll just specify I'll just specify some information in here. Alright, so I'll just say client underscore adder dot send underscore family is going to be AF underscore init, and the port is going to be port 9001, and we then specify the address, which is s underscore adder and the address is going to be inet_adder, and the IP address is 192.168.1.2, right? And now we have specified the information which we need, but I'll actually comment the important things out. So I'll just say, I'll just make a comment in here saying creates a socket structure, creates a WSA data structure required for WinSock initialization. And we can comment this one too. We can just say create a structure required by the connect function, and we can also comment something in here, print out the error and exit out of the program. And now finally we can connect to our target server. So I can just say connect, and first of all we have to specify the socket which we have created, which is client_socket in here. So I'll just say client_socket, and then we have to specify the pointer to the structure which we have created, and the syntax over here is actually going to be a bit different. So in between two brackets you specify sock adder, and then you put a star and asterisk over there and asterisk sign over there, and then you basically pass the address of the structure which you have created. So it is client_adder, and then you finally get the size of the structure, which is size of client_adder. All right. Now finally, as you have connected to the server, you can actually receive data. So what I'll do is I'll actually first of all declare two variables in here of char data type. So it is basically going to be an array. So I'll just say char receive data, and the size of this can be 500 bytes, and I'll also declare another buffer which is going to be send data of the same 500 bytes, and it is going to have a message called hello from the client. And now we can just first of all receive, as if you remember, in the server side we actually are sending first. So on the client side we'll have to receive first instead of sending, or else our socket server and the client, both of them are going to get stuck. All right, so we can just say receive, and the receive function takes the socket, which is client_socket, and the buffer, which is recv data, and the length, which is the size of the buffer, recv data, and finally the flag, which is going to stay 0. And then we can just print out this the data received from the server. So we can just say printf server, we can just say data from the server, and we can just print this out, recv data, and then we finally send to the server. So it's basically going to be client_socket. We have to specify the socket at first, and then we specify the buffer which we want to send, and then we specify the size of the buffer which we want to send data, and the flag at the end. All right, and then we simply cut off the connection, which is close socket function, I guess. Yep, close socket function. And then you specify the socket which we want to close, which is client_socket. And then we use the WSA cleanup function, which is basically going to clean up everything. All right, the sockets and the every other thing. Now we finally can just say return 0 at the end, and once again we'll actually yeah, I actually have to remove that dot over here. Now once again we'll actually put quotes comments, sorry, not quotes, so that you all guys can understand what is going on. I forgot to put up a comma in here. So now we use the connect function to connect to the target server. We receive data, so receive data from server, send data to server, close the socket connection and exit, right? And everything looks good. So let's actually compile this. So I'll be using my Visual Studio build tools to compile it. So I can just say, I'll just open up a terminal. So 2015, I'll just copy the path to it. And now I can simply compile it using the CL compiler, alright? So I can just say cl.exe-tc socket underscore client.c, and there we go. We have our socket. We have the final executable over here. So now we can just go back to our Kali Linux machine and we can test whether this works or not. So I'll just go back and I'll just run my socket server. And I'll go back to my Windows machine and seems like the connection was successful. And as you can see on this, if we go to the server side, it says client has sent hello from the client. And if we go back to our Windows machine, as you can see, we have the data which was sent by the server, which is hello from the server, which is exactly the same which we had specified in the server side code. As you can see, to confirm it that this is working, we can actually change this. So I can just put some random text in here. We can just say hello world, or we can just say make sure to subscribe to ActiveXSploit, and we can once again compile this, and we can just run this off. Now if I go back to my Windows machine and if I once again run the client, as you can see, the data sent from the server is make sure to subscribe to ActiveXSploit, and everything over here works. So that's all for today's video. I hope you enjoyed it and learned something new from it. In the next video, we'll be having a look at how we can leverage this simple socket client to a fully working reverse shell using Windows API. Alright, so make sure to subscribe and leave a like on this video. I'll see you guys in the next one. Bye bye and stay safe.